Oh, hello, lovely humans. Welcome to Math Mondays. I am your host, Jen Foxbot. In this next exciting edition, we're going to look at scientific notation and talk about how we can use scientific notation to understand numbers and as a way to do mental math with very large and very small numbers. Yay! So it's kind of a trick. Number one, because scientists and engineers like to be lazy and also save page space. So scientific notation helps us write really big or really small or long numbers very shortly and succinctly. And it also helps us better understand these numbers. And so I thought it was very relevant because recently I read a report that was talking about how billionaires are the leading cause and contributor to climate change. So what does that mean? What does it mean to say that a person has $1 billion? Or what does it mean to say that the planet has 7 billion people? That's a lot of people. And for someone to have $1 billion when there's 7 billion people, that means one person has a large amount of wealth, disproportionately so to the rest of the population. And so let's try and understand that in terms of numbers and math. Cool. So, what is scientific notation? Well, it's a shorthand way to write numbers. So let's use a number that's more common to us, like 1,000. So if I want to write 1,000 in scientific notation, 1,000 has 3 zeros. So I write it as 1 times 10 to the third, because 1, 2, 3, 3 zeros. And just like you should do with your other math teachers, always check the work to really understand what this means. So the reason why this works is because we can think about this like an equation. So this means 1 times 10 to the third power, or 10 3 times. So 1 times 10 times 10 times 10. I'm just putting parentheses around that to make it a little bit easier to read. And so either we can do it in our head, because 10s are easy to work with, or you can use a calculator. 10 times 10 is 100. So then we get 1 times 100 times 10. 100 times 10 is 1,000. So now we get 1 times 1,000. Whoops, one more zero. Haha. And that is 1,000. Boom! QED. No problem. Cool. So that's how scientific notation works. It's just a different way to write a number. With the number 1,000, it doesn't seem to help us save that much space, right? Like that's about the same amount of space. So let's try some bigger numbers. Well, 1,000,000 has 6 zeros. 1, 2, 3, 4, 5, 6. So how would we write that? We count the number of zeros. We get 1 times 10 to the 6th. Yes, exactly. Cool. And if I had, say, a 3 here, I would just change this so that in your equation it would just be 3 times 10 to the 6th. But for simplicity's sake, let's keep this as a 1. And what about a billion? What does a billion look like? Well, a billion has 9 zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 1 times 10 to the 9th. You got it. All right. My little 9 over there. Hopefully y'all can see that. Oh, that's funny. My handwriting slopes down. Anyway, so this is how we write large numbers in scientific notation. So as you can see, as the number gets larger, this takes a lot of space on my chalkboard. That's too much space. I want to do more interesting calculations. So we can save space and time by using scientific notation. What does this look like for small numbers, for decimal numbers? Well, let's use another simple example. I'm going to write 1 1,000th, which looks like this. Huzzah! In scientific notation, we can do the same technique, but we're kind of going backwards in a sense. So this is going to be 1 times, and then instead of counting the zeros after the 1, you count the zeros after the decimal point. And so in this case, or I guess you count the digits after the decimal point. Sometimes they're not all zeros. So we get 1, 2, 3. So if I want my 1 to be in front of the decimal point, that means I have 3 digits after the decimal point. And honestly, when the numbers get pretty big, I do tend to count by hand. So that's okay. So in this case, it's 1 times 10 to the negative 3. Why is that? Well, when we have exponents that are negative, that's actually just another way of writing a fraction. So for example, if I were to say 1 to the negative 1, that's going to be 1 over 1. And since 1 is kind of boring, that's also just 1. If I were to say 10 to the negative 1, that equals 1 over 10. So, if we want to do the math for the negative exponents, what does the equation look like? Well, let's write it out. So, this equals, right over here, 1 times 1 over 10 times 1 over 10 times 1 over 10. 1 over 10 3 times, and we can do the same mental math to figure out the denominator of our fraction, so that we get 10 times 10 is 100, and 100 times 10 is 1,000, so again we get 1 over 1,000, and that is just 1 over 1,000. So boom, we got what we started with. Yay! Okay, so how do we do math with these things? This is kind of weird. So let's do a little bit of a calculation. Let's ask, what is 1% of each of these numbers? I feel like this is pretty relevant because for most of us, $1,000 is a lot of money. And so 1% of $1,000 would be something that you might use to treat yourself on the weekend. So, maybe you want to save, but allowing yourself to treat yourself a little bit is important, right? And so you want to know how much is a reasonable amount of money for you to spend on a given weekend. You want to know what 1% of $1,000 is. Okay, so we can do that by writing 1,000 times 0.01. What's another way to write that? Well, let's use scientific notation. Huzzah! So that is 1 times 10 to the third times 1 times 10 to the negative 2. And so when we're dealing with exponents, and we have numbers that look very similar, we actually can just combine the numbers. Well, it only works if we're multiplying. So if we're multiplying numbers with exponents, we can actually just add the exponents together and then do the operation that is dictated by the exponents. So for example, if this was a positive 2, I would say 3 plus 2. But since it's a negative 2, I would say 3 minus 2. So this equals 1 times 10, 3 minus 2, which is just 1 times 10. Which is what? 10! Yeah, exactly. Oh, boom. Not a problem. This is a way for us to do complex math in our heads, because we can use these little tricks to make it easier. Alright, so 1% of 1,000 is 10. What is 1% of a billion? Well, definitely going to need to use scientific notation to help us solve this one. So, a billion is 1 times 10 to the ninth, and then times 1%, which is 1 times 10 to the negative 2. Just like we did with 1,000, we can focus on the exponents to solve our problem. So in this case, we get 9 minus 2 is 7, so 1% of a billion is 1 times 10 to the 7th, which is 1 with 7 zeros after it. So if I count, 1, 2, 3, 4, 5, 6, 7. So 1% of a billion is 10 million. So you know how on a weekend you were like, cool, I can spend $10 and treat myself, no problem. Tight, I can go out to brunch or something. Someone with $1 billion, if they wanted to treat themselves on a weekend using 1% of their wealth, they could spend $10 million. That's pretty crazy. Yeah. So this is how math can help us understand the world around us and identify, particular problems in our society and also how to resolve them. So yay, math. Please let me know if you have any questions about scientific notation, or if you would like to submit a math problem that we can tackle together. This episode, or this series, Math Mondays, is here for that. So please send me your math problems. I would love to work on them with you. Alright, so thanks for watching and see you next time. Bye!